Hey guys, these are a couple of calculations just to teach you molar mass if you're still unsure on how to do it, and also formula writing. All right, so this problem here says, what is the molar mass of iron 3 sulfate? And when these Roman numerals are written in here, basically I'm giving you the charge already, okay? If it says iron 3, I've given you the charge of your cation. Iron is plus 3. Right? Notice your metals are always your cations. Why? Because they lose the electrons, right? They completely transfer the electron to the anion. And the anion in this case is sulfate, all right, which is your polyatomic, and you should be looking at your polyatomic charge. So sulfate is your -2. That's the charge of sulfate. Those who are in honors usually have to memorize the polyatomics. And there are a bunch of, if you go on quizzes or Quizlist, there are a bunch of, quizzes on there to help you memorize, or you can make note cards. But those who are in regular chemistry, they don't have to memorize. And they're usually given these charges. So what you're doing is you're going to take and swap the charges, and you get Fe2SO4 parentheses 3, because there are 3 of SO4s. Now, another way to understand this is, easiest thing is to just swap the charge. Another way to understand is this. There's Fe has a charge of +3 and SO4 has a -2. Somehow we got to balance the charges so that their overall net charge is 0. So if I put another Fe +3, that's 6. SO4 -2 is 4. Another SO4 -2 will be 6, right? 2 + 2 + 2 is -6 charge. This is only the charge we're adding here, okay? And then 3 + 3 is +6. So +6 minus 6 is 0. So net charge is 0. And that's why you do this swapping, to make the net charge 0. So now let's go to our molar mass. How many ions we have here in this formula? We have 2. How many sulfurs? This is distributive properties, guys. So when the parentheses open up, whatever is outside, the inside gets multiplied with it. There are 3 here. So that's 3. And then how many oxygens? 4 times 3 is 12. Oops. Let's fix that. That's an easy fix. And then you go to your periodic table to get your average atomic masses. So I have mine here. Sulfur is 32.07. And then iron is 55.85. And then oxygen is 16. I just rounded it. And of course, these are all grams per mole. So now you're going to multiply these, and you should get 111 oops. All right, 111, if I can get it right, 0.70. And then 96.21, and then 192.0. Next thing you do is, you're not done yet, okay? You have to add these up. Add all of them up, okay? And you should get 399.8.91 grams per mole. And this is your molar mass, all right? So that's how you do that. Next problem says, what is the volume of 36 moles of methane gas, CH4? So we're going from volume to, we're going from moles to volume, okay? So circle, underline, whatever, we always start with what's given to us, 36 moles of CH4. I'm gonna set it up like this. And when you look at your mole map, you will see, and those who don't have this mole map, there are a bunch of them floating around on the internet, and you can use those, okay? If this will let me go down. So you're going from moles to liters, okay? Because it said volume. So you're going from here to here. So you're going to put 22.4 liters over 1 mole. So you're going to put 22.4 liters over 1 mole. So you multiply those and you should get CH4, 806.4 liters methane, okay? And your mole units are going to get canceled. And so this is your answer. So a mole of a gas always has 22.4 liters in volume, okay? And that's STP conditions, all right? You guys are not familiar with that, just use your mole map and know that this is the conversion and that's the way you use it. Hopefully it makes sense.